All right, I usually don't end in the middle of a problem, but I got interrupted, so, and could not go back and edit the previous video. So let's finish up this problem. It looks like we're getting to x equals 0. So we can graph a couple of points, 0, negative 1/4, and it looks like 0, 0. Those points are not very close to each other, so it looks like we might have to use slope. Yeah, I think about all we have here is graphing a point at negative 1/4 and using a slope of positive 3/4. So I'm going to go up to 1, 2, 3 1/4 and go over 4, and that will be our next point. And now I have 2 points, and I'm going to call this good. I don't like graphing y-intercepts that are fractional. It doesn't mean a whole lot, but nevertheless, this is the way sometimes these problems come out. Let's go to example 6. Find the equation of the line in the form of y equals mx plus b or x equals c. So x equals c is going to be where your slope is undefined. And our slope here is -2, so that's not going to happen with this problem. Best way to start this is y minus y1 equals mx minus x1. If we substitute our numbers that were given, the point and our slope, then let me see, the y1 is -1, x1 is 1, and our slope is -2. Okay, when the book asks for point slope, it probably will do this simplifying, but unbelievably, it'll leave it just like this. So you do the substitution, and then you might have some signs to simplify, and that's it. So when the book asks for point slope, it'll have this. Now, this problem asks for slope-intercept, which is not a problem at all. We're just going to, slope-intercept is y equals mx plus b. All we have to do is simplify and solve for y. So simplifying that distribution, -2x plus 2, and then solving for y, I'm going to subtract 1 from both sides to get y equals -2x. 2 minus 1 is 1. So point slope is right here. That'll agree with the answers in the back of the book when they specifically ask for that. Slope-intercept is right there, and we could graph that easily if we wanted to. Example 7. Find the equation of the line in the form of y equals mx plus b, parallel to the line -3x plus 4y equals 8. Okay, so what we have to do for parallel and perpendicular, we need to solve the equation they gave us to clearly see the slope. Okay, and when we see that slope, we're going to use the same slope. Parallel lines have equal slope. Okay, so let's go through the steps to solve this for y so we can clearly see the slope. I don't really care that my y-intercept is 2 because all I need is that slope. M equals 3/4, and my point is 8, -2. I just rewrote it so I could label it over here because I ran out of room over there on the left. I'm going to start with point slope. Substituting our y1, our m, and our x1. And we're going to simplify that and solve for y. Okay, 4 goes into 8 twice. 3 times 2 is 6. Example 8. All right, yeah, I'm going to put that on this video. Same idea, but it's perpendicular. Okay, so perpendicular slopes, flip and change sign. This equation is already solved for y, and here the slope is -3. So my perpendicular slope to that line is going to be positive 1/3. I took my -3/1, I flipped it, and I changed the sign. They call that negative reciprocal. All right, I've got my point. Okay, so y is 4, slope is 1/3, x is 1. All right, I'm going to add 4 to both sides. Got some fraction work to do. We don't have to graph it. Minus 1/3. Now, I'm going to multiply both 4 and 1 by thirds to get that 4 into thirds. So 4 times 3 is 12. 1 times 3 is 3. Let's put those together to finish and get it in slope-intercept form. The last thing I want to show you is the solution to problem 108. Okay, I have it there because it's even and you don't have that solution in the back of the book. All right, I will see you in class.